continue covering Rust toolchain and metaprogramming concepts, let's talk about macros, which are metaprogramming. In other words, macros are code that writes code. You write some code, and when you build your project, macros will overwrite that code, expand that code, much like how the compiler pre-processes and there's symbols and constants getting overwritten everywhere and so on. Macros are processed and produce code that you didn't write directly, but that you wrote how it should be written in a macro. And they are good at reducing repetition, especially in places where Rust's strict borrow checking kind of requires repetition. They allow multiple platform targets. You already can do this with Rust compilation, but I mean where you have code that is different from, for example, one network to another network. You can easily have one compilation version, one built WASM that's for a certain platform and one that's for another. They let you enforce patterns. You can use macros in situations where you want to enforce certain code patterns and not have willy-nilly handling of authorization or assertions and so on. And logging, for example. You want to have a consistent way to do that. You can use macros, and they, in general, let you do compile time computations and optimizations. So macros are, again, code that writes code. We'll go through all of these macros pretty quickly. These are some of the most important macros you'll see. They're built in either to Rust standard library or to, in the case of Serde macros, which aren't here, to the Serde library for serialize and deserialize. And they're good for things like error management. I put not in production up here because these will throw. So they're excellent for tests or for situations in your code where you really want to throw a dirty error. But usually just for tests. We have panic, which we've discussed before. It's a macro. And we have assert, which will assert that whatever the first statement is resolves to true. Can be a function call, can be an equality statement like it is here. Otherwise, you throw the given message, panic with the given message. And assert equal, which is just a shortcut to say I want this to be equal to this. Otherwise, panic with this message. You could obviously do it like with assert like this. I do sometimes, but assert equal is also helpful, especially when you have complex constructions on either side of that equality. Learn is brought to you completely free because of our great sponsors. Neutron, enabling developers to build breakthrough applications and onboard users from anywhere. Osmosis, the premier decentralized crypto exchange. And Obi, the smart new standard for asset management. Quick detour here. The println macro, for example. Println is not a built-in function. It's not part of core Rust. It is a macro. I'll go to this definition, and you'll see an unusual, if you've never looked at macros before, an unusual language here used with the macro rules macro, which is itself a macro, to establish println. And we println, and if there are no arguments, then we print just a new line character. And if there are arguments, then we print, and we actually use the format macro in the println macro, which we'll talk about in a minute. So this is what macro definitions look like. I know there's a lot of dollar signs around everywhere, and it might be unclear for you how to write something like this, but you should at least get the idea of what's going on. They're very good for collection creation. Format is good to make a string out of a bunch of things. You want to create a string, and you have numerous different values. And for here, they all need the display trait. So if they are built-in types that have the display trait, strings, integers, and so on, or that you've derived or implemented the display trait on, then you can use it like this. Otherwise, you can do this one as well for the debug trait. If the debug trait is implemented on the type, you can print it out like this, and it'll print out a little less pretty probably, with more information for debugging, but it will still print it out. And format lets you take all of your types and smash them into a string, or multiple strings, smash them into a string in a way you normally can't. The vec macro is a way to create a vector from an array. Often people will use vec new for this as well, the new method on the public new method on the vec class. And this will create a new empty vector too. But I tend to use, just to be consistent, I do tend to use the vec macro with empty array braces. I think it's shorter. I even think it's cleaner. You could go either way. You can do this as well, where you not just specify the array in array notation. In this case, you have a number of accounts and you have 1,000 repeated that many times. But you can also just feed it an array and say, hey, please make this a vector for me. There's also an alternative to format, basically, or a limited alternative to format called concat, and other macros for collection creation available that you might see. Placeholder macros, I call this places where code is incomplete or unreachable. It's just a macro that handles if the code reaches there, even though it's not supposed to. Unimplemented means we didn't write this code. It doesn't necessarily indicate we want to write this code. It just, we didn't write this code. Maybe it doesn't, we shouldn't be written here, or it's an example and someone else is going to write it. Maybe we're not sure yet. To do, however, it does the same thing, but it says code not implemented yet when you have the output here, and it's a to-do statement. So you can put a to-do macro into code. It's better than a to-do comment, because if your code does reach there, you'll throw and you'll say, oh, no, not implemented yet, panicking. Because there's a to-do here. And unreachable is what you put where semantically code is required, but logically that block should never be able to be reached. And some examples here, this is not actually a very good example. I would argue that you shouldn't do this, because if there are other kinds of actions that are unhandled, it will just, like, it just throws unreachable, right? We probably want to just axe this line, and then the compiler will catch when there are action types that we haven't covered. But if we want to include that unreachable there, if we do hit that, it will throw this shouldn't be reachable. And this is good for cases where, let's say you auth check somewhere, and then in some other place in the code, you have kind of an assumption the user is admin, but if they're not, it should be unreachable. You've already done the auth checking, you don't need to do the auth checking again. Or something else where you've already ensured that a number is within a certain range, and you haven't typed it out that way. You just ensured that it's a certain range, and then later you're matching and you handle numbers that are greater than that. You mark it unreachable because it shouldn't logically be able to get there. Macros are also useful for logging. Now, I generally either use println or write my own logging function. But in smart contract contexts, you should be aware that println won't get like outputted by the node, as a message, or generally on platforms, it won't get outputted in production. But debug nodes will often output it. So as you're testing locally with cargo test, unit tests, your local network, you can access the println logs and log yourself information. Println comes with format built in. You notice I don't have to call a special format macro in order to get these variables into the string. I don't need special, like a call format here or anything. It just works with built-in format. If you have the log crate available, there are these other macros. I've seen debug used and so on, but I don't tend to import the crate when I would like to just write my own macro. And what I'd really like is traceability. Whenever I'm outputting information or error messages, about my code, I want to be able to specify the line and file the error occurred on. That's useful information, helps streamline debugging, no matter how comprehensive and well-defined my errors are. Here, we have some useful macros for that purpose. File, line, and column tell you exactly where the message is coming from. And you can put it in an error message too. It doesn't need to just be in a print line output. You can put it in a string that's attached to an error and print that out, or into a panic message and print that out. And file will resolve to the file path, not the full file path. You're not going to get your username in there, but the file path relative to the crate, relative to the project. And the line will return the line number. And if you're really nitpicky, the column will even give you the exact character at which the error occurs or the message is being printed. Module path is just an alternate way to do the same thing as file. It will give you the module path in case you have files with multiple modules or you just prefer that output. And so you can construct your own macro or your own function that uses these macros in order to give more detailed output. Now, matches is something I debated even including, but you will see it. And Clippy, which is Cargo's style recommendation and formatting tool, which we'll cover in the Cargo lesson, Clippy will sometimes tell you to use matches. Matches asks whether the first argument matches the second. In other words, literally, if you put a match statement on this first argument, would it end up in these arms? And so you don't need to be exhaustive about it like a match statement. It's a little bit more streamlined than if let or calling is some or something like that. But semantically, it's just the same as doing something like this. I want to check if the user role matches some admin or some moderator. I can do it this way or any number of other ways, or I can just do it this way. And then the nice thing here is that it is a little cleaner to be able to list multiple arguments here. Unlike in this case, however, matches can also take conditions. So I can ask matches, hey, tell me if this is a typo, which should be a lowercase u. Tell me if the user's role is some role and its user, and then process the attached data that's attached to that enum value, and tell me if its level is greater than 5. And if it is a user role with a level greater than 5, then we'll return true, otherwise false. So you can streamline some conditions where if with an if let, you would need multiple statements here in order to make this work. It might be cleaner, especially within something like a filter closure. And I definitely use matches within asserts quite a bit, where I want to assert that something is true in a test, and the thing that I'm asserting is matches. It's whether a value matches something. And that might be like, I want to match the error, but I don't need the exact error string to be matched because it could be any of a number of strings. Or I want to match that the value is within a range of values and so on. So it's very useful, especially in tests, and that's where Clippy will often recommend it. If you want to write your own macro, it's a little bit more complex than you might think. You can get an idea of what's going on here with this example min macro, where I can come in and ask the compiler to give me the minimum of any, like a series of values. And this plus just means it can continue ad infinitum. So I can continue to feed it values and it will give me the minimum value. This particular example isn't very useful because you probably don't need to know the minimum at compile time. Maybe if it's some kind of config thing, you might just put the minimum value in or put the lowest value in. But it would come in some case where you wanted the minimum value and you wanted that to be pre-compiled. It could be known ahead of runtime. You can come in, write a macro that will do that for you. I really picked the example just to show you some of the ins and outs of macros. We will definitely write our own macros. I've written a few for my last project related to code cleanup, cross-platform, as I mentioned, and my own logging. And I think that we will write a few in the courses to come, but you don't need to write macros right now. Just wanted to show you what the definitions looked like. If you want to learn more about macros, and even if you want to try your hand at writing some and learn about Rust's powerful metaprogramming tools, you can go to heretolearn.xyz, if you're not already there, /macros, and find out more about macros, learn from the interactive Rust learning book on macros, and check out all the other videos and exercises in this course, and indeed other courses dropping soon. This course's content is almost done, but after a few odds and ends, now it's time to take that smart contract that we fired up in Quick Start and expand that and do some other final exercises and actually deploy that smart contract to the blockchain. So we're moving out of learning Rust concepts. You're going to have a couple of rapid fire, larger exercises coming up, and then final deployment and final exam. I'm glad you've made it this far. Can't wait for you to submit that final smart contract for grading so that you can pass Rust for smart contracts and be that much closer to being a Rust for smart contract engineer.